Hi, congratulations on all your learning in plate tectonics. And this video is going to pull a lot of that learning together to help you understand some of the geology of some places all over the world. I hope you enjoy it. We're going to start back at the beginning when we built Pangaea, and we saw that many of our continents fit together like puzzle pieces. While that wasn't enough data to convince some of you on its own that the continents have moved, and good for you for being hard to convince, as we started to add on more data, for example, different fossils that are incapable of swimming the vast oceans that now separate these continents, rocks that have so much in common, and yet when this puzzle piece kind of comes together, they seem to match up. For example, the Appalachian mountain chain matches up with mountains in Morocco as well as mountains in both the UK and across Scandinavia. Glacial evidence suggesting that southern part of Africa, which is now very, very tropical, and in fact, here's where the modern day equator runs, right through Africa, right here, actually was the center of an ice sheet, and that's only likely if it was down at the South Pole. So this is all evidence that where the continents are now is not where they've always been. So geologists, having pieced that together over the years, have been able to see the evolving, changing shape of our continents and our oceans. So here it's showing 240 million years ago to 220 million years ago. Now, this is a really beautiful animation, but I like this one even better because it's got our modern geographic boundaries on it, and it's got a couple of things that are really interesting. It's got these blue lines, which are showing subduction zones, and then these red lines are spreading centers, and then you're going to have some, I think the green lines are transform boundaries. So here's the United States, and you can see it's smushed up against Africa. Now, one of the things that I want you to notice, and we'll get back to later, is there are entire land masses that don't seem to be present on this map. For example, I'm covering up all of Central America. How can I do that? Well, we're going to talk about that in a bit. But I want you to, so here we are back at 221 million years ago on this, according to this map. And as I start allowing things to happen, I want you to notice what happened right there. This is the beginning of what we call the Proto-Atlantic Ocean. The Atlantic Ocean at this time begins spreading. It is as in a mid-ocean ridge, and you can see that this is a spreading center here. So at this time, this crust is incredibly young, and this is now, of course, the blue, very old rocks that you can find along the coast of North America and Africa, and that's a pretty cool thing to be able to see right there. This is what it would have looked like when it was new. And again, I want you to notice that North America broke off first. So this is called a rift valley. Now, I'm hoping that you're wondering if there is anywhere in the world where this is happening today. And in fact, the answer to that is yes, indeed. There is a place in the world where this is occurring, and that's called the African Rift Valley. So we're going to go zoom in on Africa. This is the southern part of Africa. Here's Madagascar, in case you need me to remind you what that looks like. Here's Africa right here. Africa itself is actually in the midst of a rift situation. So let's show what we're going to kind of pan up on this video through this rift valley. And you can see where Kenya is. And all of these red zones right here are showing where Africa is actually breaking apart. And I want you to notice that it connects with two other rift valleys. Now, if we were to fast forward on our map of the world and watch the ocean continue to grow, press play there. We're watching the Atlantic Ocean continue to grow. I want you to notice that Saudi Arabia right now is tucked into Africa. And then I want you to pay attention to what happens late in the game. So here we are right now. We have the Atlantic Ocean has grown. And yet Saudi Arabia is tucked into Africa. And I also don't know how familiar you are with the shapes of the East African nations, but these are really squished right now. And what's going to happen is that there's a spreading center that kind of inches its way into right and squeezes right in between what is now the Arabian Peninsula and Africa, and also has a third arm that comes down here through Africa. And so the African Rift Valley kind of runs from the Red Sea, Gulf of Aden. All of this is a spreading center, like so. And it runs all the way down, separating the Horn of Africa from the rest of Africa. And it literally is a great rift valley. There are deep, deep valleys here. You can see that there's oceanic crust in between. This is a beautiful picture of being inside this valley, and these are basalts. These are the same kind of rocks that you see on the seafloor, and they tend to cool in this kind of neat columnar way. This is a basalt rock, and they form these great cliffs, and off in the background are the highlands. So it's kind of being pulled apart, and you get these super low areas as a result. And so that is one modern day example of a place that is going to be evolving. And actually, if we keep going with this, you'll actually see that eventually they're going to pick up into the future, and you'll see that, that's going backwards. I'm sorry. Okay. Now, at the same time that we're watching the kind of evolution of the development of the Atlantic Ocean, it's also worth noting that meantime the Pacific Ocean is actually shrinking, and the Pacific Ocean itself is surrounded by all of these subduction zones. So if we watch this happening, this Pacific Ocean took up a huge chunk of the world, but here it's getting smaller and smaller, and you can see that it's starting to kind of, the plates are kind of subducting over there. And just in case you can't remember what subduction looks like, this is what's happening there. And again, as subduction takes place, it creates melting lava, and that rises and fuels volcanoes. This is why we have what's well known as the Ring of Fire. And the Ring of Fire is a series of volcanoes and highly earthquake-prone areas that ring the entire Pacific. And I want to draw our attention particularly to this part of the Ring of Fire, which is Central America. Let's go back to this map right here, where Central America, according to this, is non-existent. And how can I get away with doing that? If we were to go back in time to this right here, again, you can see that there is no, like, all of southern Mexico and Central America is somehow like just not there. How is that even possible? Well, this is the part where we think about the fact that volcanoes, what comes out of volcanoes is new rock, and new rock cools and becomes new crust. And as a result of that, you actually have a really big chunk of our Earth that is new. This entire peninsula from southern Mexico all the way down, this kind of umbilical cord to South America, which of course was how people probably traveled to South America originally, and I'm sure many animals have moved down through there. This is new crust. It wasn't there hundreds of millions of years ago, and it's all formed because of volcanic activity, because of this Ring of Fire. And that's pretty neat too. That explains that there are many places in the world where there's new crust, and Central America is an example of one of them. Of course, if you look across the Pacific, parts of the Ring of Fire, the entire Aleutian Islands, the Kamchatka Peninsula here, the entirety of Japan, the Philippines and Indonesia. There are many, many parts of this world that are fairly new because of the action of plate tectonics, subduction. Now we're going to zone in on one of my favorite parts of the country, which is, of course, the Western United States. I love to talk about it. It is such a big old mess, and it's not just a mess geographically, but it's a mess geologically. And I hope you guys recognize this map that you often see hanging in my classroom. So here we have the Rockies, the Front Range of the Rockies. We have the Basin and Range province. Here's California with all of its mountains. Here's the Colorado Plateau, and of course the Grand Canyon, which I love to talk about as well down here. This is a mess. We've already talked a little bit about Yellowstone being a hot spot, but understanding the rest of the geology is going to take a minute, and it's a really, really fascinating story. So let's get to that. We got to start by understanding where the plate boundaries are, and I've actually encouraged you to actually draw in and label your plates on your map as kind of the final job for preparing for tomorrow's assessment. Not that it's essential, but it kind of helps you kind of put it all together. And I want to focus on the Western United States and these two plates right here. There's one called the Juan de Fuca plate, which is off to the west of Seattle, Washington, Oregon. And then there's the Cocos plate here, which is kind of parallel to southern Mexico and central. This animation is going to show us what's actually going on here. This plate right here is called the Farallon plate. So this is off the coast of North America. You don't recognize all these states out here because they're a little squished right now. But North America, the Farallon plate, again, is actually these two plates combined before they weren't. So let's watch what happens. Here is, these are the four corners. This is New Mexico, Arizona, Colorado, Utah. Here's a very squished Nevada, and it's a very, very squished California. So what happens here? This Farallon plate is being subducted, and then suddenly I want you to notice what happened. This part right here, let's rewind just a second. This is a spreading center. This is a transform boundary, but these perpendicular lines to these lines are spreading centers. Again, a spreading center is a mid-ocean ridge, okay, where new crust is coming up. It's uprisen, but there's this rift valley in the middle of it. So what just happened there? I want you to notice that what happened was a spreading center got subducted. Now this is a very strange idea, but let's watch it happen. So this spreading center just got sucked into this trench and it got subducted. And as a result of that, the spreading is actually continuing under the crust, and it's spreading out and creating California. And then there's a transform plate that is moving Southern California and Baja California north relative to the North American plate. Do you remember me talking about that when we talked about the San Andreas Fault? This is actually what's happened here. And this explains this big mess that is the Western United States, because that spreading center is currently, to geologists' current thinking, and they're sounding underneath our plate, they're finding, using, kind of sonar-like technology, a little bit more complicated than that, but they're finding that there appears to be a spreading center right down the Basin and Range province of Nevada. The Basin and Range province is a series of high cliffs, like that, okay, with volcanic activity and hot springs in the middle, like the East African Rift Valley, and these very low spots in between. In fact, the lowest spot in the lower 48 states is here in Death Valley, which is one of these drop-down blocks because of the stretching of the crust here. On either side is uplift. We have the Colorado Plateau, which lifted up in the last 5 million years, and as a result of the erosion that ensued, we have the Grand Canyon, and of course that's all been deposited down here, where the Colorado meets the ocean, the Pacific. We have the uplift of the Rockies, the exhumation of the Rockies. We have this uplift over here. Why is there uplift on both sides? Because on both sides of a mid-ocean ridge, it's lifted up. That's why it's a ridge. And then there's a rift valley in the middle. And so this explains a very strange Western tectonic regime. And, to be honest with you, it was a mystery to geologists when I was in college, and this is recent information. So it's really, really exciting that we've got some answers to some of this. Why this whole region is fairly earthquake prone, why there's hot springs in here, because there's magma pretty close underneath it, why it's stretching apart while we have these really low valleys with these really high mountains that are all kind of parallel like this, and why we have uplift in the middle of a continent where we don't normally see it. Another way of looking at it, and this may be as clear as mud to you, I get it's a little bit complicated. Here we again have a picture of the North American plate overriding the Farallon plate. It's subducting, and then down on this late Cenozoic picture, you have a spreading center underneath the continent. The continent is overriding it, and that is causing what we call crustal extension, which is stretching of the crust. On one side, you have the Rockies on the eastern side, and on the western side, you have the Sierra Nevada, which are the highest mountains in the lower 48 states. That's where the highest peak, Mount Whitney, is. Actually, about literally 80 miles from the lowest place, which is called Death Valley. There's actually a race where you can go from Death Valley up to the top of Mount Whitney. go for it. So that's just such a great, crazy story, and I hope you've enjoyed it. One of the things I will really recommend that you do, of course, is to go and label some of these plates so that you just kind of can complete that picture for yourself, ready for tomorrow's assessment. So I hope you enjoyed